Thanks everyone for joining us on the Cloud Native FM podcast, a show that brings all the latest, and greatest news in the cloud native ecosystem. And today we will be talking about it's all about base images. Yes, it's all about base images because if you're skewering all the infra but still using the vulnerable base images, you have opened the doors for all sort of supply chain attacks. And boy, oh boy, this is the most important, complex topic to learn for a lot of people. But for me, concept seems to be enjoyable when I am talking to my best friend. Today is the day, the first time my best friend and the best evangelist from Sigstore community joining me all the way from Turkey. Thanks, Batu, for taking your crucial time out, for sharing the most critical knowledge of the cloud native era. And once again, thanks for showing your presence. And now, Batu, over to you. Can you introduce yourself to my audience? And then we can start the agenda. Over to you, Batuhan Apayadin.
Hello, Saim. Thanks for having me. Actually, this is my first live stream in English, so everybody has to bear with my English. This is an actually historical moment, right? So thank you so much, Saim. You encouraged me to do that, right? So I am really appreciative about that. So my name is Batuhan, but everybody knows me as developer guy. They didn't even know my real name. So my name is Batuhan Apayadin. I have been working for Trendwell for 4 years, and I have been doing an open source for just 1 year. So this is how we met each other. So thanks for having me. So what I really like to do most is writing blog and helping people about the technologies that I interested in. So I do write some blog posts on several organization blogs. For example, Flux, Kyverno, CD Foundation, that kind of blogs. So here we are going to talk about securing base images by using Kyverno, also co-project. So today we have so many things to cover, right? So people can find all the usable information in our blog. This is actually based on a blog we wrote recently in the Kyverno website. So yeah, thanks, Salim.
Thank you, Batu. Thank you for the wonderful introduction. And yes, we are covering your blog on the live stream part of it. And I will add the link into the description of this YouTube video so everybody can hop into the nirmata.com and enjoy learning the Batu blog on that. So let's hear the agenda for the day. Container images are typically built from a base image, so it is extremely important to ensure that base images do not contain any vulnerabilities and are secure. This podcast is all about how to enable end-to-end security for your base images using open source projects such as Kyverno. And we want to prevent our container from running unallowed base images. So in this podcast, we need to have a build information at runtime in for container image builder, providing build information, and search for simpler Kubernetes policy engine. So we will be learning how to extract build information using Buildpacks, KO, Docker Buildkit, and we should be determining which base images can be used and which of them cannot before allowing them to run on production system. This is where Kyverno comes in really handy. And now, Batu, now you can start sharing your screen and guide us through on how to secure container-based images end to end. So now, Batu.
Thank you, Saim. As you said, there are so many things that we need to cover today. So let me share my screen. Hope Hope you can see my screen right now, right?
Yes, Batu, absolutely. I can able to see your screen.
Okay. Okay, then let me start, right?
Yes, absolutely, absolutely. You guys.
Okay. In traditional builds, we are using some base images, especially people maybe know about them as parent images. Those things are something similar. So someone says base images and someone says parent images. Those are equal. Those are equal things. Okay. So we are talking about base images here because generally, when we are building container images, we need them. Why? Because people there is two reasons for that. Because people might not know about how can they build images from scratch. So it is kind of a hard thing. Yeah. The second reason is why we are using some base images. It is because using them is easy, right? Because we don't need to do anything about them. So they are here, they are there in the graph or some other public registries. We are just referencing them and use them in our container images while we are building based on that. So that's a good thing. But if there's something that isn't good enough, is the vulnerability count included in the base images. So we need to be more wise while we are choosing the base images of our container images. Generally, people know. Let me clarify one thing: what is the base image and what is the parent image? In general, when we are using something like from scratch, this is the base image. But if we are referencing an image in the from directive in one of our Docker files, is the parent image. But in the ecosystem, people generally using these terms for the same thing. Okay. Yeah. This is a quick reminder for people. We are going to talk about the parent image concept, but we are referring them as a base image. Okay. It is an important to talk about how we are actually building container images today. So here you can see that these are the layers for one of the popular base images named Ubuntu. So we are generally using this image while we are building our container images. Just we are saying that from Ubuntu and to run working directory, these kind of things. And when we start a container from an image, there is a layer that created for us that you can read and write. This is the difference from an image and the container. So it is an important because you can't build something secure unless you make the base image secure, right? So today, in the pipelines especially, we have some scanners, vulnerability scanners, and so many pipelines has included already this kind of vulnerability scanners into the pipelines to find which are the vulnerabilities do my container images have. So we all know the risks, but we didn't aware of them until some of the organizations come up and say that all the popular base images are vulnerable. So as I said, we cannot build something secure unless we make the base images secure. So today we are going to learn more about how we can choose our container images more wisely and how we can validate that information in the runtime to help our teams or help organizations to determine that these kind of images that are only be usable in the production systems. So we are covered end-to-end scenario while building a container images. While building a container images, we are going to extract build information from them. Then we can use that information in Kyverno to validate the base image that was used while building a container images is as secure base images. So there are so many things that we need to cover today. So while we are doing this, we are using some container image builders. So everybody might be familiar with one of these technologies, but there is Docker is not only a tool that we can use to build container images. So there are many. For example, Buildpacks. You can use Buildpacks to build your container images easily. Also, one of my favorite container image builders code that we are going to also cover what code do for us, what can do call for us. There is another, which is also my favorite, BuildKit. BuildKit is also another container engine, but we are using a call. We are using a tool called Buildx that uses BuildKit under. We will cover all of them in the upcoming sessions. As I said, so many organizations are actually doing some research about the base images. So two of them is ChainGuard and Slimai. If you can reach out to these reports, you will see that there are so many vulnerabilities available in the popular base images. Let me switch back to my browser and show some of the results from the researchers that Slimai and ChainGuard did. So there should be some. Let me find the PDF here. Here you can see some kind of information about base images, popular base images actually. So is there any vulnerability data available? Yeah, yes. This one is this picture is this picture is tells about these are base images actually using in the that we are all using as base images. For example, Node. For example, Debian. For example, Red Hat, Ubuntu, and Alpine. And these numbers are showing that the vulnerability count that are found about them by using some of the tools, for example, 3B, Grape, and Docker Cynic tools. So as you can see that, as we expect, this should be 0 because unless we build them as a secure manner or unless we reduce the vulnerability count to 0, we can't build something secure while using one of them as our base images, right? So industry is trying to make these kind of images secure. When I say secure, I mean the vulnerability count is 0. Okay, so none vulnerability exists in these base images. So yeah, it can be doable, but we are not going to cover them today. But we are especially interested in these base images, how we can actually use one of the base images that we consider as secure. Yeah. And this report is from the Slimai company, and it also shows us that let me find here. The report actually is the second report that contained Slimai reported and announced. They said that 60% of public containers have more vulnerabilities today than we saw a year ago. So it's really an important risk that we need to cover. Okay. Also this information is also an important, because it says that today's average public container has 287 vulnerabilities, and 30% of which belong to a high and critical category. So it is an important risk that we need to find a solution to protect us from this kind of vulnerabilities. Okay. Okay, let me back to the slides. This is an also important topic, because security is not a static thing. As the CMA report says, that vulnerability count increases and increases day by day. So the word is important, because the image with known vulnerabilities today suddenly becomes a vulnerable image tomorrow. Because, as I said, security is not a static. Someone found a vulnerability about that image, and we need to be aware of that. The image is now has vulnerabilities. But we have some solutions, right? We are using some vulnerability scanners like 3D, like Grape, like Docker C. So we can scan our base images to identify vulnerabilities and try to make them less vulnerable by applying patches against vulnerabilities before allowing people to use them. So we can protect ourselves against those risks by choosing our container-based images wisely, or maybe we can build them from scratch. So there are some tools that can help us to build our container-based images from scratch by using a different approach. Maybe we can talk about them in the later live streams, but today we are trying to choose the most suitable base image for us, that we know that there will no vulnerabilities in it. So yeah, let's continue. So we need to take a look at the bigger picture. So first, we are using a container image, as we call base images. So we need to choose these base images wisely. Okay. Then in traditional Docker builds, no one can say that this image is used, this image as a base. So there is no information about the base images that are using while we are building our container image. So we need to do some work around to capture this build information while we are building our container images. It is a new concept that are many tools included in their code base. The first one, if I remember correctly, let me share my browser again. Jason Hall, who is one of my favorite container dudes. Yeah. He also pointed out this problem in his proposal. So as you can see that when building and securing a container image, it is important to consider the security of your base images. Because in lots of cases, even if your code is perfectly secure, if you are based on an insecure base image, it doesn't matter much. Okay, so we need to find a way that we choose our base images wisely and the most secure ones, let's say. But the real problem is that today, if you are using a Docker or some other tools, you cannot find this information. What is that information? Which kind of base image is used while building your container image? at that time. Okay, so Jason is also pointed out that problem and created a proposal for that. What is the problem? The problem is once your image is built, information about the base image is completely lost. So we are using these base images just for assembling the root file system or some of the tools that we need in the final images. But no one can say that this base image is used while you are building your container images. So we need to find a way. We need to figure out that problem by doing some things, right? Today we are talking about 3 tools, which is Buildpacks, Co, and Buildx. Those are figuring out the problem, but in a different ways. Co uses something called image annotations, which is Jason proposed to apply them on OCI image specification. Today we are looking at the proposal that Jason started a while ago, and this proposal merged into the upstream OCI image spec. Now you can find it in the OCI image spec repository, in the OCI image repository also. Okay, so let me find annotations here. Yeah. Now you can see that these annotations are included the OCI image specification as well. Yeah. But in this proposal tells us the whole story. Okay, we need to start to understand what those annotations are meant for. So here we can understand that. Okay, Jason said that we need to create new annotations, which is the OCI solution of the problem. Okay, because Docker Buildx or Buildpacks uses another approach to gives us the build information, or some blogs are also referring the build information as reproducibility. So still people need to figure out the standardization of giving that information to people, which base images are used, or that kind of stuff. So let me clarify a bit more. Co uses that we will see in the upcoming sessions. Co uses this approach, the OCI solution, using the image annotations to tell people that these base images and the digest at that time are used to build your container image. Okay. Yeah. As I said, these proposals are approved and merged into the upstream. So it is some kind of standardization right now. So whenever you build an image with Co, you will get these annotations in your OCI image manifest. By the way, Saim, if I not remember correctly, that people who might not be familiar with OCI concepts, you recorded a live stream with Brandon Mitchell. So people can watch this talk to learn more about the OCI stuff, right?
Yes, absolutely. Absolutely. Great point, actually. I will try to add the link with the Brendan podcast as well on the link, and people can listen to that. So thanks for pointing out, Batu.
Yeah. Thanks for making it same, because Brandon is also another my favorite container dude, right? Brandon is knows a lot about OCI. Yeah. Let me back to the slides. Actually, can we? Yeah, we can talk about the other solutions that these tools provide. So let me share with you one more solution that this time BuildKit provides. They call it build information, and they provide a way to capture these build information from the image build. What they are actually is doing is that they are using labels. Okay, they are using labels to gives us the information about which base images and I think I need to mention one more thing to describe that solution. In general, what people know about building container images more secure and small is something we call multi-stage builds, right? So in Cole's solution, there is no way to identify that which base images are actually being used while building container images. But in BuildKit's approach, in Docker file, there can be more than one from statement in that Docker file, right? So in BuildKit solution, it provides all the information, all the base images that are referenced from the from instruction. We can see all of them in the build information that BuildKit provides. But in Cole, there is only one information, and this information is about the final images, image space image, okay? So here is the information that BuildKit provides about which base images are being used in while building our containers in the Docker's from statements. Those are the images that are used while building a container images in the from statements. We will see in the upcoming sections, and it will be more clear for all of them, for all of you. They created another flag called metadata file, and this metadata file helps us that this base image information can be outputted into the file named metadata.json. Okay, if you do not provide this flag, it will be included into the container images config. We will take a look all of the image manifest and config to see what are the how this build information actually can look. So we will see in the upcoming sections. So yes, there is something called front end. This Docker image is being used. This Docker image is also being used. This is an also important thing. Once you specify the build information, you will not see any build arguments included into the build information. This is some kind of a security thing, because these kind of attributions generally used by developers for secrets. So you need to, if you want to include this kind of build argument information into your build information, you need to specify something called build info attrs true. So this is an important thing that we need to talk about, but we will not cover it today. So one more thing, the last container image builder that also provides build information, but they call it as reproducibility. So this is the point that I am talking about. We need to build some standardization to provide this kind of information from container image builders. So someone says build information, someone says reproducibility, someone says the OCR image annotations. They also call it reproducibility because once you have this kind of build information in your hand, you can use this information to rebuild your container images. Because as you see that there is an also, you can also do this, you can also use this kind of information to pin your container images to digest. As you might be familiar with that. Once we use this kind of tag, it actually points out to a digest. So it is an important thing because the content behind this tag can be changed. So at that time, when I am building my container images, if I am using something here, docker.io/library/alpine 3.15, this is actually pointing out at that time this digest. So we can use that information later on to build our container images, and those digests, actually those references are pointing to the same digest. We are using we are actually doing some sort of pinning, right? We are pinning the images to its digest, to its contents. Okay, this is why they call it also reproducibility. If I remember correctly, one of the developers in the Docker team told me that they will use that information to actually rebuild the container images. So this will be an important thing, at least for the Docker Buildx, to rebuild container images in a reproducible way. Okay, and this is the last example that we are going to talk about today. You might not be familiar with Buildpacks, but if I remember correctly, Saeed is also recorded a live stream about Buildpacks. Am I right, Saeed? I don't remember, but you.
I think for Buildpack, I haven't recorded as of today anything for the Buildpack part. We'll try to do it in future.
Okay. But in Buildpacks, it also uses an annotations, but they are not using the OCI image annotations. They are using its own annotations. They define some annotations, and the annotations that they use those annotations to do the same thing, but the annotations is a bit different. Okay, there is a field called run image.reference. They are using that to provide the base image information to us. What OCI image annotation does, it uses this annotation, and Buildpacks is using something different. So this is why we are going to talk about capturing the build information for these tools. So if you are using Buildpacks, you need to do something different. If you are using Buildpacks, you also need to do things in different. If you are using code, you also need to do something different. Okay. But today we are going to cover all of them. So at least we are covering all of them. Okay, let me switch back to the slides. Okay. How we can create build information that contains some valuable information, including which base images were used while building container images. But wait a minute. We mentioned that a container image is just a collection of layers. So how do we identify which base image was used during the build? Unfortunately, for any client that pulls your image, there is no way of knowing that which base image was used during the build process, which means that once your image is built, information about the base image is completely lost. Until now. Fortunately, various container image builders have come to the rescue to address the problem here, such as Buildpacks, and Docker BuildKit, which we are going to see in the upcoming sections. We will discuss all of them and show them how they can provide this information. So let's start with Co is a simple fast a.k.a. is a simple and fast container image builder for Go applications. Luckily, one of the core maintainers of the Go project, whose name is Jason Hall, worked on an RFC for contributing Open Container Initiative image spec about adding the base image annotations concept into it. You can access the details of his work from here. Let me switch back to my terminal. Here is the specification that Jason Hall wrote. If you want to learn more about the RFC that he wrote, you can reach out to the blog post from here. Basically, this RFC is all about adding the base image annotations into the OCL image spec. So finally, OCL approved his RFC, and now we can add these annotations above to the image spec manifest to identify which base images were used during the build, which is precisely what code does for us for free, as you can see from the new annotations here. This one helps us to know which base image were used during the build, and the other one is the immutable digest of the base image at the time the image was built on it. So let's see it in action. First, I need to clone one of my example repository called Hello World code. So let me cd into it. Okay, now this is a straightforward Go application. There is nothing special in it. But the only thing we should mention is that you might notice that there is a .co.yml file here, as you can see. In that file, we are specifying which base image is going to be used while building the container image. The default base image config is necessary for this example because there is an issue with annotations on Docker type images. Docker manifests don't support annotations, and base images are Docker type and not OCI. Hence, we should use GCR/distro/static as the base image for specify platform, or for example, specify a platform all flag to make manifests that supports annotations for Go. Set base image annotations to set base image annotations successfully. Once we clone the project, there is a command that we need to run. Let me copy an example from here. So there is nothing special about the command we run here. So let's run it. Once the image build is finished, we can take a look at the manifest to see base image annotations of an image. Oh, okay, so let me switch back. Let me switch it. So let me do it one more time. So it's related to my credentials, so I will replace it with the jcr.io, so it should be fine. Okay. What's the problem? Oh, sorry. I need to replace my username here. So that should be okay right now. So let me copy the image here. And let's see the manifest of it. As you can see from the output above, code did what it claimed it would do and set these annotations for us. Here, as you can see, the corresponding image spec annotations here. The base image and the base digest. Okay, nice. So let's continue with the other container image builder, which is Docker Buildx. Docker Buildx is built on BuildKit. BuildKit is a concurrent, cache-efficient, and Docker file-agnostic builder toolkit technology, and a CLI plugin that extends the Docker command with the full support of features provided by the mobile BuildKit builder toolkit. To install Buildx, we can simply refer to the installation page here. So let me copy the installation page. Here, as you can see, there is a special installing section for install Buildx. In addition, BuildKit V010 comes with a set of shiny new features. One of them is the new build information structure generation from build metadata. This allows us to see all sources, for example, images, Git repositories, and HTTP URLs, and configurations passed onto your build. This information can also be stored in different ways, such as within the image config or a file. We can get more detail about the process from this link. Let me switch back to my browser here. You can search for buildrepro.md. You can reach out to the file that describes all the details related to the image build configuration. Sorry. So, while this feature is automatically activated upon updating the BuildKit V010, we also recommend that using BuildKit's Docker file v1.4 to reliably capture original image names. We can also do by adding the following syntax. For example, let me show you as an example. Here is the syntax keyword. We can easily enable this feature by adding this syntax keyword on top of your Docker file. As we said, we can store this information in various ways. For example, to keep it in a file, we should use the metadata flag. For example, let me show you. By the way, we can create a new Docker container type builder config, because we need to create a Docker container builder, which is the recommended way of capturing the BuildKit information. So let me create a new builder instance, and we can talk about the metadata flag later. So let me create a new builder called my builder. Once the builder is ready, the next step is to build the project, and then we can use the metadata file flag to capture the build information. So let me quickly copy. Let me clone my project first. Here is my project. You can reach out to my GitHub repository and search for hello world Buildpacks. cd hello world Buildpacks. The first thing you will notice is that a Docker file is designed to highly optimized and cache efficient for the Go application. Don't worry if you are not familiar these kind of optimizations that happened in here, or you can reach out to my other blog post to see and learn more about the Buildpacks project. You can visit the Kubesimplify blog. Here, you can search for the secret games behind building container images, enter BuildKit and Docker Buildx. You can learn more about Docker Buildx project from here. Okay, now it's time to start building the container image. So let me easily build my container, but we need to replace this one with the GHCR container registry, and I think I should put my username here, and we can easily use metadata.json to extract the build information into a file. So let's try. It's building now. Once the build is finished, so what's wrong? Oh, I need to set the Go version. It's a build argument because I designed it. I designed it as well. Once the build is finished, we will have a look at the image configuration, not the manifest. Because, as we said, Buildx can keep this information within the image config instead of a file. But in this example, we used metadata file flag to capture the build information from to allow BuildKit to save it into a file. So let's have a look at the metadata JSON file. As you can see from here, the sources section includes all the image references that we used in the Docker file. Here as you can see. So let me show you. Here, this from section basically says that this image was used during the build, and this image was also used during the build. So I have all these references from the in the sources section of the build information. So what if we can remove the metadata file flag? So now we can easily search for this manifest, and we'll take a look at the images config. So to access the images config, we need to first find its digest. Digest will point out to the image configuration. So let's have a look. Here as you can see that this information is stored within a new file called mobi.buildkit.buildinfo.v1. So let's have a look at this information in more deeply. You should see the exact output of the metadata JSON file here. But there is some differences because we need to enable some kind of flag to actually capture the all other build arguments, because these information is considered as secure options. So we need to enable them to say BuildKit is also has to upload these build arguments to container registry. So it's nice. Finally, we will have a look at our next container image builder that provides the build metadata is Cloud Native Buildpacks. Buildpacks for short. Cloud Native Buildpacks transform our application source code into an image that can run on any cloud in the simplest form. Cloud Native Buildpacks embrace modern container standards such as OCI image format. To get more detail about the blog, to get more detail about Buildpacks, we can reach out this official blog post here, buildpacks.io, official website, sorry. Before diving into the details, we need to first learn some jargons about the Buildpacks, such as build and run images. Build image, build image, which is a base image used to construct the build information in which the build kits will run. The run image, on the other hand side, a minimal base image used for the final application image. So, in the next section, we are going to try Cloud Native Buildpacks to build our application. So, let me switch back my terminal. Is there any? Okay, let's rebuild to Hello World code project again, but this time with Cloud Native Buildpacks. So as I mentioned, the minimal base image used for the final application image is the run image. So we need to capture the run image information within the image config because it is the base image that BuildKit sets for us. Okay. The remote image will have an image digest reference, the run image dot the reference field into IO buildpacks dot lifecycle dot metadata label. So let's build our project. So as we do previously, we need to clone the project. You can find the project in my GitHub repository also. So what is the problem? I think I need to make it public. So let's search it here. It might be private. Oh no, I haven't created it. So no problem. No problem. So we can easily use another project, for example, co. So let's switch back to the core project, and this is the command that we need to run to build OCI container image with Cloud Native Buildpacks. It might take too long, but let's wait. Once the build is finished, we will have a look at the image configuration, not the manifest. Because this is the way of Cloud Native Buildpacks uses to store the build information for an image. Sorry. What? What is the problem? I think I need to remove the whole folder. This is unintended file, so we don't need to use it. So we don't need to use that. It's an unnecessary folder, so it's my bad. Yeah, this time it should work. Nice. It's an exporting image right now. Nice. Now it's time to push the image. Nice. Oh, very nice shortcut for image config. So here, as you can see, that we need to find the run image reference. As I said, there should be a life cycle. The life cycle, I don't know. Let me find the correct. Where is it? Yeah, this one. Here is, as you can see that, let me make some pipe operations to grab the exact image that is used during the build process. So we will get the correct image that was used during the build process. Here, as you can see. Nice. But last but not least, now we come to the section where we'll discuss how this information can be used. This is also where policy management tools like Kyverno come to the rescue. In order to make Kyverno work, we need to create a Kubernetes cluster first. So I am going to use kind for my testing Kubernetes cluster. So Kyverno is a policy engine designed for Kubernetes. Kyverno policies can validate, mutate, and generate Kubernetes resources, plus ensure OCI image supply chain security. Now, we will use Kyverno to validate the base image metadata information, as we saw in the previous container image builder examples, of the images we have built with several techniques. In order to do that, we're going to use Helm, because Kyverno has Helm chart. So let's have a wait for kind to create the testing cluster for us. It might take times, so please be patient. Now it's starting the control plane. The next step will be creating the Kyverno, deploying the Kyverno by using Helm. Okay, it's time to install Kyverno on the kind cluster that I created earlier. Okay, now let's have a look at the Kyverno pods. Wait for them to successfully deploy. It shouldn't be too long. Once the Kyverno pods are ready, the next step will be apply the previously mentioned Kyverno policies. For example, allow base images for validating the base image information against the allowed ones to ensure it's a good base image. So, we need to create a config map that is going to be used to store the allowed base images. In order to make the example work, we need to create a namespace called platform. So, let me create a allowed base images config map here. As you can see that we are allowing the base image defined here as one of our base images that allow to be used by other images. So let me clone the example Kyverno policy here in the enforce mode. So let me have a look at the cluster policies, allow base images. Here, as you can see that this policy basically tells us that Kyverno will extract the base image information from the images manifests annotation, which is the way of code did for us, as we saw in the previous examples. Then we will use that information to basically validate that is the image extracted from the image base name annotation is in the base images config maps the allowed base images key. So let me quickly have a run some of example images here. For example, the base image. Kyverno shouldn't be allowed me to do that. So as you can see that Kyverno throws an error. Allowed base images validation failure. This container images base is not in the approved list or is not specified. So if I can use one of my images that I have built with core, for example, this one. So I need to replace it. Container it should work. Okay. So this error comes from the Kyverno side because I am using a private container registry jhcr.io. So I need to rebuild my container again, but this time I am going to use some of the registry which is only for testing purposes. So and it's public. So I am going to use the public container registry as an example to not struggle with the authorization process for the sake of simplicity, basically. So let me switch back to this one with the TTL and it should work because oh no, what is the base image? So let's have a look. Oh, we are using the chain guards base images. So we need to add that into the config map to basically say that this image is also a secure image. Sorry about that. So here I need to add the chain guard space image also. So let's close this. Okay, let's retry again. Let's try again. And it should work right now. Yeah. So let's have a double check. Sorry about that. This one. It should throw an error. Okay, nice. But the last thing that we need to talk is that the I think we need to talk about the day 2 container base image operations. So what if the base image we described here, a vulnerability discovered about the base image we used in day 0. So for example, out-of-date software is a major factor in security breaches. All base images should be continually updated and aim for 0 known vulnerabilities. New vulnerabilities are constantly being discovered and pop up every day. You want to update the base image to get rid of some of vulnerabilities, but don't want to rebuild them from scratch, because as we saw in the previous examples, the build process might take too long. So we need to find a way that only change the base image layers and remain the other layers same. So this is a technique we call rebasing. To exactly do that. So rebasing is a kind of updating technique with the old base image onto a new base image. Basically, during rebasing, layers above the original base images are snipped out, placed on top of the new base images, then pushed back to the registry. The rebase image can be tagged over the original image or given a new tag. Fortunately, we have various options that support rebasing images such as Crane and Buildpacks. For example, I can easily say that Crane has a subcommand called rebase. So let me basically show an example. And so let me basically replace my image described in here. I know that this was the base image was used during the build, and I am going to replace it with the GHCR1, and I am going to give a tag to the rebased base image here. So let's have a run it. It says that it's not the old base, so I am going to replace it with the chain guard one, because we saw that we are using the chain guard's base image as a base image of our container image, so it should work right now. So let me quickly show the base image information. So I think I might. Sorry, I missed check here. Oh, this one. Nice. So let's use this one and use chain guard as the new base image. Yeah, it says it's pushing the base image. So let's have a look at the build information again. Now, as you can see, we are using the chain guard as one of our base images. So that's nice. But Pack, on the other hand side, has also a rebase subcommand that allows us to quickly swap out the underlying host layers, for example, run image of an image generated by Pack, built with a newer version of the run image without rebuilding the whole application. Let me quickly show. This will basically rebase, or let's say update the base image of the image that we defined in here with the latest version of the run image. So it's the Peg way. So that's all for me today. That's all for me today. Thanks for watching. Thanks for attending. Thank you so much, Saeed. So see you.
So thank you very much, Batu, for a wonderful demos on letting people know about how to extract build information and how to restrict vulnerable base images by making a policy engine in front of them.
So now some of the questionnaire that I have come up with, I mean, my mind come up with at this moment of time. Can you please tell my audience more about reproducible builds? Can we make reproducible builds as part of the CI/CD system?
Yeah, thank you so much, Sam. Reproducible builds are a hard topic, but I don't know much about reproducibility, but there are different ways of providing reproducibility. But at the lowest level, reproducibility means producing byte by byte equal artifacts from the source, from the same source code, no matter where you trigger the build. But here, as we are talking about building container images reproducibility. So as you already know, takes for images are more like human readable links to an image, but we shouldn't rely on them, as the content digest pointed out may be changed. Build information is more like pinning the images we reference during the build process, because we usually use other container images as base images to build the actual images to a digest to make them immutable, which means that we can use this build information to reconstruct the same container image later on, because now we have the digest that we used during the build process during the build process of an image previously.
Thanks, wonderful for the wonderful explanation. And now the next question: can you tell my audience if container image builder they are using not supporting the build information? This means there is no way to extract the build information. So what should people do? And tell us some tips to migrate to a container image builder that support build information. So over to you, Batu.
Yeah, thanks, Saim. That's a really good question too, because actually the first thing that came to my mind is that if you are building an OC image, hopefully you can usually one of the tools that I mentioned in the demo. They can help you. For example, let me give you some examples about the tooling: Scopio, Crane, and Reg-Client. These can help you to work with container images in your local environment, and these are also can help you to mutate your image by adding annotations designed explicitly for specifying the base image information, as we saw in the code demo. There are two annotations designed specifically for the base image information, and you can use one of the tools that I mentioned, Scopio, Crane, and Reg-Client, to mutate your image manually. So they can help you to specify the base image information easily and quickly, because this is the way of OCI follows.
Yeah, thank you. And the last question for this session is how the relationship would be in the future between OCI images and the build information and the supply chain security, SBOM, etc.
Yeah, this is an also hot topic these days, because an OCI reference types working group has been working on an issue for a while to provide the new API called Refers API. Refers API means is more like making references between OCI images and their relationships, such as attestations, SBOM, vulnerability scans, and build information, maybe much more easier and maintainable. So finally, their effort has been merged into the upstream OCI repository recently, which means that we will start seeing all the relationships of an image in one place. Thanks to the OCI reference working group for their amazing effort.
Thank you, Batu. It's been a wonderful session with you, and I learned a lot. And thank you very much for explaining wonderful these questioning answering session has been a wonderful one. Is for me. And if I missed some of the question during the podcast, you can please type those into the YouTube chat channel, and I can definitely add those in the future discussions as well. And you can always stay ping us on Cloud Native Boy and Developer Guy on the Twitter handle as well. So let's wrap up the discussion for the today's podcast. Container images are typically built from the base images, so it is extremely important to ensure that base images do not contain any vulnerabilities and are secure. And this podcast, but to show us how to extract the bit information using KO, BuildKit, and BuildKit and how to enforce your policy engine to not deploy the images that are vulnerable based images. So we should always be careful while choosing them, because if we don't pick them wisely, we can encounter security problem. According to that, we should be determining which base images can be useful and which of them cannot before allowing them to run on production system. And this is where Kyverno comes into play. To do so, we should access the base image information of the container image first. This is where build information concepts come into the picture. Thanks to KO, Buildpack, and the Docker Buildx, we can provide build information while building container images. So that's all we have for the today. And hopefully next time you will be able to find out some of the solutions that help you extract the base image information, and you'll have a policy engine like Kyverno, which makes sure that the images that you are using in production are secure. And thank you very much for everyone for tuning into this podcast and Cloud Native FM channel. Hope to meet you again in the future with another episode. And stay healthy, stay safe. Bye bye, everyone.